The purpose of a guidance system is to point those engines, which are at the bottom of the rocket, point them in the right direction so that the vehicle gradually ascends off the launch pad and then tilts in a desired trajectory to wherever it is you're trying to go. In the case of the Saturn, it would go into Earth orbit, and then once everything was checked out there, it would restart and go on its way to the moon. Basically, you get from the ground into space in about 10 minutes, or less sometimes. And there is no way that a human being can really make a lot of decisions about controlling that operation. It has to be done automatically. That all has to be done in a very careful sequence with split-second timing. You have to be sure that one thing is jettisoned before the next one is lit, and then you do it again. The third stage takes over after the second stage burns out. So you have this very complex choreography of burning, of staging, of the gimbaling, the swiveling of the engines to keep it balanced, the tilting in the right direction. All of that has to be done by the onboard computer and the guidance system, which in this case was contained in that instrument unit. The early versions of it were shipped down the river, down to the Mississippi and over to Cape Canaveral by barge. That was a slow process and it was not really optimum, but in the early part of the Saturn program, a vehicle became available that NASA very quickly seized upon, and that's the so-called Super Guppy. It was basically a Boeing Stratoliner that was expanded, its fuselage was expanded to handle very, very large payloads. The instrument unit was wheeled into the Super Guppy, and it took off from Huntsville and flew to the Cape directly. The Saturn V instrument unit was one of many, many parts that were built all around the United States and were brought individually to Cape Canaveral, where they were brought into something called the Vehicle Assembly Building, one of the largest buildings in the world, and they were stacked one on top of each other, all bolted together and then wheeled out to the launch pad on this massive thing called the crawler transporter. The Apollo 12 mission was a very interesting one. It was the second mission to the moon, and it was launched from Cape Canaveral during some cloudy weather.
3, 2, 1.
As the rocket ascended into space off the ground, it had this enormous plume of flame coming out of the engines, which created a path of electrical conductivity, like a lightning rod. The rocket, therefore, conducted electricity and received a couple of very, very big lightning jolts, which knocked out essentially all the signals on the command module. Everything either went blank or turned red. Things were just completely shut down. But the guidance system in the instrument unit was designed to be rugged enough to handle situations like that. It kept working. They made it into orbit. Once they were in orbit, they were able to reset all the circuit breakers and realign the gyros on board. They went to the moon and had one of the most successful missions of the entire Apollo program.